Class we have seen the introduction of supervised learning. Now let us see what is a decision tree. And decision tree is one of the technique that is used in classification. And the algorithms that are used for decision tree are ID3, C4.5, ID3 which uses information gain, whereas 664.5 uses gain ratio. And apart from information gain and gain ratio, there is another measure called as Gini index. So this is the data. So this is a decision node where age attribute, the first one is called the root nodes, and the roots are branched according to the values that age have. Age have three values: young, middle, and old. Okay, according to the values that the attribute have, that many branches will be there. And uh, the last labels have the classes, and these are called as leaf nodes. And in between the root node and leaf nodes, the nodes are called as intermediate nodes. Yes. So if you see at the end, you have values. What are these values? 2 by 2, 3 by 3. See, కాన్ఫిడెన్స్ కదమ్మా డేటా చూడండి హ్యాస్ జాబ్ దగ్గర ట్రూ వాల్యూస్ హౌ మెనీ ట్రూ వాల్యూస్ ఆర్ దేర్ వన్ age young has job true. How many records are there? Age young and has job true. Two records are there, right? Age young and has job true. You have these two records, third and fourth. Okay, so out of two records, how many values are S? 2. Have you understood? Out of two records, how many class values have the value S? So 2 by 2. See, previously in the first slides, we have this question. We need to identify the value of a class value of this. So without learning, by seeing the number of dominating class values, we have decided that the class value is S. But now the data is trained, the model is trained, and based on the data, we have learned that the value is no. See, by construction of this decision tree, we have decided the age is young, then has job is false. Obviously, the class label is no. When you write algorithms, will all algorithms lead to the same decision trees? Have you understood my question? When you write the different types of algorithms, will all algorithms will give the same results? No. But what is in the case of association? When you write two or more algorithms, the association rules should be same. But here in this case, when you use different algorithms yields different decision trees. And when when the resultant tree, when you see the result, the tree should be smaller and accurate. So as finding the best, there you have many number of trees. Finding the best tree is considered as NP-hard problem. And all the algorithms in for decision trees are heuristic algorithms. So once you have constructed the decision trees, from the decision trees you can generate the rules. So for example, see here we have constructed the rules. If own house is equal to true, then the class is S. If the decision tree includes two or more attributes, then it should be separated by comma. That is, own house is equal to false, has job is equal to true, then association class is equal to S. So what type of rules we are generating here? What type of rules we are generating? Last ఈ rules ని ఏమంటారు? When class is included, it is called as class association rules. Right. You have already have idea about decision trees. When you are constructing the decision trees, what is the criteria for stopping the algorithm? So you have selected one route. Okay. Again, after that, you have selected another route. Up to how many routes you will select? What is the stopping criteria? Decision trees మర్చిపోయారా?
నో మ్యామ్ క్రైటీరియానే కన్ఫ్యూజింగ్, అంటే గుర్తులేదు.
క్రైటీరియా గుర్తులేదు, కానీ ఇక్కడ నీకు డెసిషన్ ట్రీ కనిపిస్తుంది కదా, ఎప్పుడు స్టాప్ చేసావు చూపు. డెసిషన్ ట్రీ చూసి చెప్పండి, ట్రై చేయండి. ఎవరిది ఆన్సర్ ఇచ్చింది? సాయి కృష్ణనా? కాదమ్మా, ఇంకోటి. ఎనీ అదర్ గెస్? ఒకటి గుర్తుంచుకోండి, మీరు కన్ఫ్యూజన్ లేకుండా ఈ డెసిషన్ ట్రీని కనుక అండర్స్టాండ్ చేసుకుంటే యూ కెన్ రైట్ ది అల్గారిథమ్స్ ఇన్ యువర్ ఓన్ లాంగ్వేజ్. సూడో కోడ్ రాయాలన్న రూల్ ఏం లేదు. సో ట్రై టు అండర్స్టాండ్. ఇది డయాగ్రామ్ అండర్స్టాండ్ చేసుకోండి. When the class labels all have a single name, no need to further classify it, further divide. All the class values should be same. డైరెక్ట్ గా ఓన్ హౌస్ 2 అయితే ఎస్ క్లాస్ వాల్యూ వచ్చేసింది. ఓకే, ఇక్కడ కూడా when all the class values are s, here all the class values are no. When all the class values are same, there is no mixed values in the data. When you divide it, then you can stop it. The first condition. And the second condition, divide చేస్తున్నప్పుడు when there is a single attribute. ఇంకా డివైడ్ చేయడానికి ఇప్పుడు ఓన్ హౌస్ డివైడ్ చేసాము, ట్రూ ఆర్ ఫాల్స్ వచ్చింది. హ్యాస్ జాబ్ ట్రూ ఆర్ ఫాల్స్. ఇఫ్ దేర్ ఆర్ మిక్స్డ్ క్లాసెస్ ఇన్ ద లీఫ్ నోడ్, అగైన్ యూ విల్ గో ఫర్ అనదర్ attribute. If no other attributes are left, then also you will stop. And what is the third condition? ఇంకొక సింపుల్ condition. One is if all the class values are same, you will stop. If no other attributes are left, then you will stop. Then the third condition is when no examples are left, then you will stop. What do you mean by example?
Data, ma'am.
Yes, records.
Yes, records.
So these are the three criteria. Remember. ఓకే, ఈ డయాగ్రామ్ ని మీరు కనుక గుర్తుంచుకుంటే ఎనీ డెసిషన్ డయాగ్రామ్ యూ కెన్ ఏబుల్ టు రైట్ ద అల్గారిథం. ఓకే, హ్యావ్ యూ అండర్స్టూడ్ దిస్?
Yes, ma'am.
ఓకే, so when you are dividing, see, this data, the attributes are categorical, then only you can able to categorize. If it is continuous value, let us see how to do in the further slides, but as of now think that the data is categorical. And tree is constructed as top-down recursive manner. From the top root node, you are go on recursively selecting the attributes and you are dividing the data. So at the start, you'll take all the examples at the root node and you'll divide the examples. And here you are selecting the own house at the root node. Why not has job on the root node? So you need to decide which attribute should be taken as the root node. This can be decided using entropy values or information gain. So the condition for stopping the partition is all the examples should belongs to same class, there are no remaining attributes and there are no examples left. Is the algorithm clear? Okay, అదే మనం pseudocode. Okay, you are taking data, attributes and training examples. So if D contains only training examples of same class, then make T as the leaf node. Else, if there are no attributes, then also T as a leaf node. If D contains example, when you will divide, if the data contains mixture of classes, then in that case, you will select each attribute and calculate the impurity evaluation for selecting the attributes. So when constructing the decision trees, you need to decide that which attribute has to be chosen for the branching. And our main objective is to reduce the impurity. So in C4.5, we use information gain or gain ratio, but previously data mining by Michelin textbook, when you have learned, the author has given that C4.5 uses which measure information gain or gain ratio na? What you have learned from Michelin Camber textbook? Decision tree algorithms గుర్తున్నాయా? ID3, C4.5, Gini index.
ఏం గుర్తులేవు మ్యామ్, ఇవేమి విన్నట్టు కూడా అనిపించలే.
ఆన్సర్ ఇచ్చింది ఎవరు?
హర్షిత్ మ్యామ్. ఎస్ మ్యామ్.
డెసిషన్ ట్రీస్ లో మీరు నేర్చుకునేది డేటా మైనింగ్. అంటే డేటా మైనింగ్ దీస్ 3 అల్గారిథమ్స్, ID3, C4.5 అండ్ జీనీ ఇండెక్స్. ID3 అల్గారిథం ఏమో ఇన్ఫర్మేషన్ గెయిన్ యూస్ చేస్తుంది అకార్డింగ్ టు మిచ్లిన్ క్యాంబర్ టెక్స్ట్ బుక్. C4.5 ఏమో గెయిన్ రేషియో మెజర్ యూస్ చేసి అల్గారిథం డెవలప్ చేసినారు. అండ్ జీనీ ఇండెక్స్ ఇస్ ద కాంబినేషన్ ఆఫ్ బోత్ ఇన్ఫర్మేషన్ గెయిన్ అండ్ గెయిన్ రేషియో. Okay, again data, loan data, right? Previous based on the values I am asking, ఈ డయాగ్రామ్ కి ఈ decision tree కి what is the difference between this decision tree and this decision trees? What is the difference?
With single attribute it is happening, and also it is not the age one is not binary.
The age? Uh-huh. Okay. Mainగా, see, if you see, the class labels are not same. అంటే when you are what is the main stopping criteria? All the class values should be same. But if you see the leaf node, it's the mixture. It ended with the mixture. Yes. So
Yes.
when the class values end with the mixture, then it is called as impurity. ఏవి కరెక్ట్ గా క్లాసిఫై అవ్వలేదు. There is a mixture. So if you see A diagram and A decision tree and B decision tree, somewhat here in this B diagram, one branch has purely classified. So that's why we are saying that B is better than A. ఇక్కడ ఏది కరెక్ట్ గా క్లాసిఫై అవ్వలేదు, బట్ అట్లీస్ట్ ఓన్ హౌస్ యాజ్ ఎ రూట్ నోడ్ we can able to get one branch as a pure. Is this point clear? Right. So information theory, you know that data mining is a combination of different disciplines. What? So it's a combination of machine learning, information theory, statistics, so on. So why information theory is important? See, information theory will provide the basis or provide the proofs using mathematics. For example, you want to invest in share market. Then what you will do? You don't have any information about the share, on which share you have to invest. Then what you will do? Then you will approach an agent, right? Share market, ever can idea on that?
Not exactly, ma'am. Rough basic idea ఉందా?
సరే, ఏదైనా సరే,
ఏజెంట్ దగ్గరికి వెళ్ళి
సార్
స్టాక్స్.
ఆన్లైన్ గేమింగ్స్ చాలా మంది కొంచెం ఐడియా ఉండి ఉంటుంది కదా. ఈ ఆన్లైన్ గేమింగ్స్ లో కూడా కొన్ని గేమ్స్ త్రూ ఏజెంట్సే మనం అప్రోచ్ అవుతాం. సరే, అవన్నీ మర్చిపోండి. షేర్ మార్కెట్ లో కనుక ఇన్వెస్ట్ చేయాలి అంటే యూ విల్ అప్రోచ్ ద ఏజెంట్ బికాస్ దే నో బెటర్ దాన్ అస్. మనకి యాజ్ ఎ బిగినర్ యూ డోంట్ హ్యావ్ ఎనీ ఐడియా. So what these agents will do, their only work is they'll sit on this website and they'll see which share is growing and which share is sinking, and based on some probabilities, వాళ్ళు will estimate చేస్తున్నారంటే based on the probabilities they are telling that okay, keep your invest on particular share and they'll give the information. So when you don't know the information, on which share you have to invest, the information that is given by the agent is very important to you. Okay, so you are paying the agent for the information he is giving. Okay, similarly, information theory will also use the same institutions, but instead of rupees, the measure here is bits. It measures the information in bits. So information theory is based on probabilities. A share, the probability he'll estimate and he'll give which share is better to be invested. Similarly, tossing a coin or Right. So that one bit of information, that is whether to invest in this particular share or not, yes or no, is very important for you, and you are paying for that. So, what is the relation between this information theory and our decision trees? So, you need to decide based on probabilities that which attribute to be selected that has to be branched. Is this point clear? Information theory ఎలా యూస్ చేస్తున్నాం అనేది, we are gaining the information, you are deciding the node. For example, first root node ఎలా decide చేస్తాం, based on the probabilities that came from the discipline called as information theory. So entropy measure, you need to calculate the entropy of the entire data based on their class values. So for the entire data, it is given as 1. The probability of what is CJ? It's the probability of class in data set D. And remember, we use this entropy as a measure of impurity. So measure of impurity annappudu entropy value should be great, high or small? Small, yes. So let us see this example. The data set D has 50% positive examples and 50% negative examples. So when you calculate the entropy value, so according to this formula, probability of class values, so you have two class values, that is positive and negative, and both positive are 0.5, negative are 0.5. And when you calculate the entropy value, the value is 1. And if you see positive values are 20% and negative values are 80%, then entropy value is 0.722. If 100% positive examples are there, then the entropy value is 0. That means here in the third case, the purity is more. In the first case, impurity is more. So as the data becomes purer and purer, the entropy values becomes smaller and smaller. The entropy value is for estimating your impurities, whereas information gain is to decide your attribute that has to be branched. So you are calculating the entropy value for the entire data set, and you are calculating the entropy value for the single attribute. Then information gain is calculated as entropy of entire data minus entropy value of single attribute. Is the definition clear? Right. డౌట్స్ ఉన్నాయి ఎవరికైనా? ఎగ్జాంపుల్ చెప్తానమ్మా, అప్పటికే అర్థం కాకపోతే మళ్ళీ ఒకసారి గెయిన్కి మీరు డెఫినేషన్కి వస్తా. విత్ ఎగ్జాంపుల్ చూడండి ఒకసారి. సో దిస్ ఇస్ ద డేటా యూ హ్యావ్. ఫస్ట్ స్టార్టింగ్ నుంచి try to understand entropy of D. Entropy of D means we are calculating on class labels. Okay, so totally you have two class labels, no and S, so you will have two values. One is this, one is this. So 9 by 15. What is this 9 by 15? Out of 15 examples, 9 are S values. So probability of S values into log 2 of S values. The first one, 6 no values are there. So totally when you calculate, it's 0.971. I'll pause for a second, try to understand entropy for D, and if you don't understand, ask me, I'll repeat. Is that clear? Shall I proceed? Only try to understand entropy of D only. Okay? Now you have calculated entropy of D, that means for the entire data. Now individually calculate for attributes. Let us take entropy of age. Entropy of age is having three values: young, middle, and old age. So when young values are there, how many S are there? Try to calculate. Do not see the below diagram. From the data, try to understand and calculate. You have three values totally: young, middle, and old. How many young are there? 5. Middle 5, old 5. So 5 by 15. Now entropy of D1. How to calculate entropy of D1? Out of 5 records, how many are S and how many are no? Have you understood age?
మ్యామ్ ఇప్పుడు ఎంట్రోపీ ఆఫ్ D1 అంటే ప్రాబిలిటీ ఆఫ్ S ఇంటూ లాగ్ S అండ్ అంటే మైనస్ ప్రాబిలిటీ ఆఫ్ నో ఇంటూ లాగ్ నో, అదే కదా మ్యామ్?
అంతే.
ఇప్పుడు అది తీసుకొచ్చి మళ్ళీ 5/15 తో మల్టిప్లై చేయాలి ఇక్కడ ఏజ్ లో.
చేయాలంతే.
ఓకే మ్యామ్.
క్లియరా? సో ఫస్ట్ యంగ్ తీసుకుందాం. యంగ్ 5 రికార్డ్స్ ఉన్నాయి. 5 రికార్డ్స్ లో నో ఎన్ని, ఎస్ ఎన్ని? 2 ఎస్లు 2 నోలు. సో minus of 2/15 into log 2/15 minus of 15 2/5 minus of 2/5 into log 2 of 2/5 minus of 3/5 into log 2 of 3/5, that is equal to 0.971. ఇది ఒకటి క్యాల్కులేటర్ పక్కన యూస్ చేస్తారా? ట్రై చేస్తారా? ఒక 1 minute పాజ్ చేయనా ఆర్ షెల్ ఐ ప్రొసీడ్?
ప్రొసీడ్ మ్యామ్.
ప్రొసీడా? ఓకే
Ma'am, one second, ma'am. Now, if we, for age, we are calculating like this. For suppose there is another root node above age. For suppose root node has age and gender as two branches. So for root node, if we need to gender, just take some example, ma'am. Gender, like something like that. So we have to calculate for age separately, gender separately, and again, how we calculated for age, same we have to do for that root node. Like just I'm asking.
You have confused. Just I have explained for age. Similarly, you need to calculate for own house. ఇక్కడ attributes చూడండి. Age, has job, own house, credit rating. For all the 4 you need to calculate.
Okay, I just got confused, ma'am. Okay, I got it now.
Is this point clear? నేను ఓన్లీ ఇక్కడ ఏజ్ attribute ఒకటే ఎక్స్ప్లెయిన్ చేశాను. పైన చూడండి, I have calculated for own house also. You need to calculate for all the 4 and then you will calculate the gain by subtracting the entropy of D minus entropy of attributes. ఇందాక ఈ గెయిన్ అర్థం కాలేదన్నావు కదా?
Yes.
Entropy of, you have calculated entropy for single attribute, you have calculated the entropy for entire data, and now you will subtract both. Once you subtracted and got the results, whichever you will have, information gain should have the highest value. So own house is having the highest value, so own house is taken as a root node. Any doubts? Right? Okay. So this is the way by using this entropy values, you are checking the impurities, and by the highest the value of information gain, the value will be taken as for branching. So this is the final tree. Now, handling the continuous attributes. Previously, the data is categorical.
Category.
Now, if you it's assume that the data is continuous. So when the data is continuous, the attributes should be splitted into two intervals. Say there you have the values, the mixed values, and the maximum value is 49 or 50. So split the data into 1 to 25 and 26 to 50. Then the continuous value will become categorical. Two categories are there. One category is from 1 to 25 and another category is from 26 to 50. So even when you are dividing, how you will find the best threshold to divide? అంటే టూ కేటగిరీస్ కింద డివైడ్ చేయమని ఫస్ట్ స్టేట్మెంట్ లో చెప్తున్నారు. ద ఫస్ట్ స్టేట్మెంట్ ఇస్ సేయింగ్ దట్ డివైడ్ ఇంటూ టూ కేటగిరీస్. వై కాంట్ ఐ డివైడ్ ద టూ ఇంటూ 1 to 20 అండ్ 21 to 50? అది కూడా టూ కేటగిరీసేగా. ఆర్ 1 to 10, ద అదర్ కేటగిరీ ఇస్ 11 to 50. సో హౌ విల్ డిసైడ్ ద బెస్ట్ రేషియో? For deciding it, what is first of all, sort all the values of continuous attributes in the increasing order. First sort the values of the attributes and then you decide two adjacent values. For example, నేను v2 value తీసుకున్నాను. Up to v2 one set, from v2 plus 1 to vr another set, and v2 I have taken v2, you may take v3 and other may take v4. So you take all the possible thresholds and calculate the gain on it, and which gives the maximum, you take that as a threshold. Is this point clear? మళ్ళీ
Ma'am,
రిపీట్
but
చెప్పమ్మా.
that may take so many computations, no, ma'am.
చాలా కంప్యూటేషన్స్ జరుగుతాయి. ఎస్, ద
That
కంప్యూటేషన్స్
is
ఆర్ మోర్.
mandatory.
అందుకే 50-50 విల్ బి బెటర్. Of the decision tree, and the decision tree is represented in the graph. For example, x value, and you have x value and y value. I am representing on x axis and y axis. When x is less than 2, less than or equal to 2, the first space, and y is less than 2.5, you will have in this space all the square braces. Okay, have you understood the diagram? ఓకే, సరే. ఈ డయాగ్రామ్ యూస్ చేసి, అంటే డయాగ్రామ్ చూసి ట్రై టు అనలైజ్ దిస్ డేటా. Results you can get if you know the algorithm, or if you know any tools how to classify, the tool itself will give this decision tree. But once the result is there, you need to understand the result. ఈ రిజల్ట్ ని బట్టి ట్రై టు గివ్ ఆన్సర్స్. మీకు అర్థమైంది చెప్పండి ఏదైనా. See, from this time you have understood the algorithms, or if you don't know the algorithms also, you have found some tools like Weka, and you have given data and it's have given result. But even result వచ్చేది కూడా దాని నుంచి కన్క్లూజన్స్ కావాలి కదా. దిస్ ఈస్ ద రిజల్ట్. Try to infer something from this result.
X has 4 partitions, X attribute. Y attribute has 3 partitions.
See, X attributes have four partitions కదా ఇదంతా ఒకటే స్పేస్ కదా. The space
Yes,
you are
ma'am.
divided, you are drawing under X axis and Y axis. Okay, sir. Something you
I
are
meant to
trying.
say, I meant
Uh,
to say on X we can split into 3. We can use 3 times to split X, something
Three
like that.
times, sir. Four ఉంది కదా. X greater than four ఉంది కదా. Here in decision tree, X greater than four is there కదా.
Yes, ma'am.
Uh,
అంటే 4 క్లాసెస్ లోకి స్ప్లిట్ చేయొచ్చు మ్యామ్ ఎక్స్ అట్రిబ్యూట్ తోటి.
చేయొచ్చు. ఓకే. Three classes. Continuous data into categorical data. Yes. Uh, I have given a data and you have divided the continuous data into categorical data and you have applied the algorithm and you got the result. ముందు మీరు అంత రిజల్ట్ కి ముందు ఏం చేయాలి, ఎలా చేయాలి అని చెప్పారు. రిజల్ట్ వచ్చాక ఏమర్థమైంది మీకు? అది కదా కావాల్సింది. వాట్ రిపోర్ట్ యూ విల్ గివ్ ఆన్ దిస్ రిజల్ట్? హ్యావ్ యూ అండర్స్టూడ్ మై క్వశ్చన్?
Yes, ma'am.
You are a data analyst. You have applied something, you got the result, and what report you are giving to me back? Sorry, okay, I don't want to drag. I'll explain. See, if you consider this diagram, we are representing the values in the space. This is somewhat like a clusters. Will you agree?
Yes, ma'am.
Yes, clusters. So this space is one. ఇక్కడ పాయింటర్ కనిపిస్తుందమ్మా నేను పెడుతున్నప్పుడల్లా?
కనిపిస్తుంది మ్యామ్.
Okay, this is one cluster, this is one cluster, this is one cluster, this is one cluster. Okay, one cluster. In all the clusters, you are grouping the data, the squares and the circles, so on. So if you see this space contains only single attribute or single value. ఈ ఒక్క వాల్యూ దేంతోనూ కలవట్లేదు. సో I can consider this as outlier. It is not mingling with any of the values. అదొక్కటే ఒక్క సింగిల్ స్పేస్ లో రిప్రజెంట్ చేస్తుంది. You need to analyze data like this. So I can consider this as outlier in between 2.5 and 2.6. Is this point clear?
Yes, ma'am.
Okay. Right. Overfitting. What is overfitting? Overfitting is called as when you check the accuracy on the training data. The accuracy may be good, but when the same thing is tested on the test data, then the accuracy may be poor. That is called as overfitting. And the symptoms is by seeing the decision tree itself, you can say that it's an overfitting. That is, the tree may be too deep or it may have too many branches and may reflect anomalies due to noise or outlier. Here it is representing noisy data. So there are two approaches to avoid overfitting. One is pre-pruning and another is post-pruning. Pre-pruning means that when the algorithms, when you train the algorithm, when the algorithm feels that the tree is growing too deep, then prior itself will stop growing. Have you understood? Before growing, when the tree is growing and growing deeply, you'll stop there. But the thing is, it is very difficult to find when to stop. ఇంకా గ్రో అవుతుంది. ఒకవేళ if you are stopping it, you don't know that what happens in the further tree. అక్కడ స్టాప్ చేసేస్తున్నాము. స్టాప్ చేసిన తర్వాత తర్వాత ఏం జరుగుతుంది, ఏ అట్రిబ్యూట్స్ ఉన్నాయి అనేది కూడా ఫైండ్ అవుట్ చేయడం డిఫికల్ట్ ప్రీ ప్రూనింగ్ లో. ఫస్ట్ ప్రీ ప్రూనింగ్, ఇఫ్ యూ ఫీల్ దట్ ద ట్రీ ఈస్ గ్రోయింగ్ డీప్లీ ఆర్ ఇఫ్ ఇట్ ఈస్ హ్యావింగ్ టూ మెనీ బ్రాంచెస్, you will stop prior itself, halt the tree constructions early. You will not further construct the tree. In post pruning, what you'll do, you will let the tree to be constructed and you will prune the branches. That is, you will remove some of the branches so as to remove the noisy data. Remember this line, validation set. Apart from the training set, tested set, you will have another set called as validation set. Do you know what do you mean by validation set? You class time machine learning, I think you have completed machine learning, right? Machine learning people know what is validation set. Tell me what is validation set. Validation set. And I think everyone has completed machine learning. మీ క్లాస్లో ఇప్పుడు whoever అందరూ మెషిన్ లెర్నింగ్ కంప్లీట్ చేశారా? ఇస్ ఇట్ ఎలెక్టివ్ సబ్జెక్ట్ ఆర్ కోర్ సబ్జెక్ట్? అందరు ఇప్పుడు క్లాస్లో ఉన్న వాళ్ళందరికీ సెలెక్ట్ చేసుకున్నారా మెషిన్ లెర్నింగ్? సరే, okay, I'll explain validation set in further slides. Okay, have you understood the difference between pre-pruning and post-pruning?
Yes, ma'am.
Okay. So, see here, in the previous example, we have seen that the data between this space is a outlier. So, between 2.5 and 2.6. So, what I'll do, I'll remove this branch. If I remove this branch, all the values will come under one cluster. This all the data is grouped together now. No separation of single item. So in post pruning, you will allow the tree to be grown and then prune the data and remove the noise. Cleared? Okay, right. So when you construct the decision tree, you can construct the rules from it. And once you have constructed the rules, the pruning rules are similar to your association rules. And before constructing the tree, you need to handle the missing values. And you need to handle the skewed distribution. Skewed distribution ఎప్పుడు వస్తుంది చెప్పండి? Yes. So you need to adjust the training set and the test set so that the values are identical. So you need to handle the skewed distributions and handle the attributes and classes with different cost. That means when you are dealing with data mining IRS law, you will assign weights for the data. So if the classes have different cost and different weights, then you need to handle that. So, till now we have taken the class values which is having only the categorical. Even if the class values are numerical, then so you need to handle that as such type of attributes also, because you know if there are continuous values, how to change into categorical values. Just now we have seen. ఇంకొక some of most of beginners what they'll do instead of going for two types of sets, if the values are nearer, for example 41, 42, 43, they'll consider all the three values are 41 or 43. సో ఓన్లీ టూ కేటగిరీస్ లోకి ఆ వాల్యూస్ అన్ని వచ్చేటట్టుగా చూసుకుంటారు, ఆర్ త్రీ వాల్యూస్ ఇన్స్టెడ్ ఆఫ్ టేకింగ్ యాజ్ ఎ రేంజ్. they'll take say for example 10 నుంచి 20 వాల్యూస్ అన్నింటినీ 10 కింద రిప్రజెంట్ చేయడం, 21 నుంచి 40 అంతా 20 వాల్యూ కింద తీసుకోవడం. సో they will take only 2 or 3 values. Attribute construction. What is attribute construction? Attribute construction. When you want to create a model, sometimes you need to create more attributes, or sometimes you will remove the attributes. If for example date of birth of a customer is given, then you will construct an additional attribute called as age. Okay, sometimes you need to have additional attributes also for your problem statement. Right. Evaluation of classifiers. So for evaluating the classifier, the measure that we use is accuracy, which is given by number of correct classifications by total number of test cases. And other evaluation measures are efficiency. That means what is the time that is taken for constructing the model and the time to use the model. Robustness, how much your model that you have created is capable of handling the noisy data and missing values. Scalability, I want you to tell me what is scalability.
For huge amounts of data, when we need to classify, it should be able to do. It should
Yes.
not provide bugs.
When మీరు try to download Veka and try to execute, some of the classifiers will not handle a large number of data. They ask, they'll simply tell that too much of data is there, try to reduce. మీకు వస్తుంది when you use Veka. And interpretability, when you are constructing the model, you see if the tree you are constructing a decision tree, if the decision tree has too deep, then understanding the tree is difficult, right? So it should be simple, the model should be simple, so it should be understandable, and the size of the and the even when you are constructing the rules are also few, not too many rules should be generated. Holdout set. Holdout set is nothing but test set. So when you have a data set D is divided into two disjoint subsets, it is training set and test set. And the important point to be remember is training set should not be used in testing the data or while testing the data. Test set and the training set should be separate. What is the difference between your ordinary programs and data mining programs? There also you are getting output, here also you are getting output. Then what is the difference between the your ordinary programming and data mining programming?
Ordinary programming takes in input and program and produces output, but
Yes.
in data mining, input data and output data will be taken, and model is given output.
Yes. Here you will give both input and output. Validation set గురించి నేను నెక్స్ట్ స్లైడ్ లో చెప్తాను, బట్ నౌ యాజ్ ఆఫ్ నౌ ట్రై టు అండర్స్టాండ్ training set, validation set, test set. Training set and validation set will have both input and output. But whereas test set will have only input, but you do not have output. Test set like here, see. Where is my example? So this is my test example, wherein I don't have output, class values. But while training the data, you will have the class values also. That is, you have output also. So this test set is also called as holdout set.
Ma'am,
And
that
this
means dividing into two is called holdout set, ma'am.
only test set is called as holdout set.
Oh, okay, ma'am.
And this type of method is used when the data set is large. Infold cross validation. ల్యాబ్ లో మనం యూజ్ చేసే వాలిడేషన్ ఏంటి? టెన్ఫోల్డ్ క్రాస్ వాలిడేషన్. See, in n-fold cross validation, the available data is divided into n sizes and ఒక్క నిమిషం ఉండండి, నేను నోట్ ప్యాడ్ ఓపెన్ చేస్తాను. Say for example, if it is, can you able to see the notepad? Yes or no? Okay. So for example, if it is 5 cross validations, so you will divide the data say into 5 groups, 1, 2, 3, 4 and 5. Okay. So you use each subset as a test set. So what you will do here, you select one. Okay, if you are selecting 2, 2 is considered the second set. The second set is test set, and combine 1, 3, 4 and 5, and these 4 sets are combined and these are taken as training set. Okay, this is one evaluation. It is an iterative process. So in the second step, you take one more subset. Now you are taking one randomly. Okay, now one will become the test set, and 1, 3, 4, 5 will become the training sets.
Ma'am,
The
2, 3,
combination.
4, 5, no, ma'am.
Sorry, 2, 3, 4, 5. 2, 3, 4, 5 will become the training set. Okay. So you'll take each and every subset as a test set and combine the remaining ones, and that will become a training set. Okay, is this point clear? So what you are, why you are calling as cross validation? Validation. You are here. These are validation sets. Validation set is nothing but you are tuning your parameters. ఈ ట్యూనింగ్ ఇక్కడ పారామీటర్స్ అంటే ఇప్పుడు ఫైనల్ గా ఏ సెట్ ని ట్రైనింగ్ సెట్ కింద డిసైడ్ చేయాలి, ఏ సెట్ ని టెస్ట్ సెట్ కింద డిసైడ్ చేయాలి. ఇఫ్ if you are taking the combinations of 1 as a test set and 2 3 4 5 as a training set, and you will get one accuracy for this. If you are taking other combination, you will get one accuracy for other thing. So whichever will be the best accuracy, you will consider that as training set and another as test set. So you are tuning the parameters to which you have to take the training or testing. Okay. Validation set లో అయితే ఇది ఎన్క్రాస్ వాలిడేషన్ కాదు. For what purpose we are using validation set అంటే ఎందుకు? You will decide what you have to take. So what happens if you are using n-cross validations? In n-cross validations, you are taking one set as training set and combining the other sets as one set as test set and combining other sets, and you are taking as training set, and you will get one accuracy. The overall accuracy will be calculated by the average of all the accuracies. Any doubts? Any other doubts? I'll repeat this sentence. Use each subset as test set and combine the rest n-1 subsets as training set to learn the classifier. And if you are dividing into n equal size, the process will run n times, giving n accuracies. You'll get n accuracies, and the final estimated accuracy is the average of all these n accuracies. And the most commonly used cross validation is 10-fold or 5-fold. And even this method is used when the available data is this method is used when the available data is not large. That is when the data is small. Shall I proceed?
Yes, ma'am.
Leave one out cross validation. And this type of validation is used when the data is very, very small. It is a special type of cross validations wherein the cross validation has only a single test example. What is the difference between the previous that is the first one and the last one? You are dividing the data into two sets in the first one, right? Holdout set, you have training set and test set. You are dividing the data into two. Here also you are dividing the data into training set and a test set. But what is the difference? If I am dividing the data into two, the test set will have only single record. It will have only single test example. If you are dividing the data into m subsets, and if you are selecting one, that one will also have single test example. You will not have more data. That's why first in the first statement itself they are saying that if the data is too small, then you will divide. See, if the data contains only 3 records, then you will divide the data into 3 subsets, wherein each subset contains only single example. Clear? The validation set, I have already discussed about what is validation set. The data is divided into 3 sets, training set and validation set. Both training set and validation set have input as well as output, but whereas test set does not have output, it has only input. validation set is most frequently used to estimate parameters, and the term validation set is mostly used in neural networks wherein you decide how at what stage you need to stop the iteration, what are the hidden nodes that are there. Okay, to identify that, you use the validation set, and whichever values are best, whichever data is giving best accuracy, you use that as final parameters. ఇందాక చెప్పాను, whichever is giving the best accuracy, that will be as a your final data. So cross validation can be used for parameter estimating. So I'll stop here. మళ్ళీ పెద్ద టాపిక్. I'll continue tomorrow. Thanks